Welcome to the DIY Honda Garage channel. Welcome to our troubleshooting guide on DTC B1776, which signifies a microphone input-output shorted to ground issue specifically for the Honda Odyssey models between 2011 and 2017. This error code alerts us to a potential problem with the HandsFreeLink (HFL) system communication, particularly with the microphone used for phone calls and voice commands. It is important to note that this issue can arise in vehicles without navigation systems that are equipped with touchscreens. Diagnosing this error correctly is essential to restoring functionality to the HFL system, which relies heavily on microphone input for usability. Systematic steps are provided to ensure that technicians can pinpoint the location of the fault accurately. We will cover component locations, possible fault causes, and specified symptoms that may indicate the presence of this error code. DTC B1776 indicates an issue specifically within the HandsFreeLink system, associated with the vehicle's microphone input and output. The affected components primarily include the front HFL ANC microphone and the HandsFreeLink control unit. The front microphone is typically located in the overhead console, allowing clear voice capture for hands-free communication. This unit works in conjunction with the control unit, which processes audio signals for phone calls or voice commands, thus playing a crucial role in the HFL system's proper functionality. If the microphone encounters a short to ground, it may disrupt system communication entirely, rendering hands-free functionality ineffective. Understanding these components helps in accurately diagnosing the issue and restoring proper service to vehicle's HFL system. Several potential causes can lead to DTC B1776 being triggered in your vehicle. Firstly, a short circuit could occur within the wiring between the HandsFreeLink control unit and the microphone, creating a direct path to ground that interferes with signal processing. This could be due to wear over time or physical damage to the wiring harness. Secondly, poor electrical connections can also lead to intermittent issues, impacting the overall functionality of the HFL system. Loose terminals or corroded connectors can prevent adequate communication between components. Lastly, a malfunctioning microphone itself may contribute to this error by failing to send or receive signals properly. Identifying these causes is vital for effective troubleshooting and repair of the issue at hand. When DTC B1776 is present, various symptoms can be observed in the vehicle. The most noticeable issue tends to be the inoperability of the hands-free system. This means that features relying on microphone input, such as making phone calls or using voice commands, may not function as intended. Additionally, you may experience a drop in audio quality, leading to difficulties in hearing conversations clearly during calls. Furthermore, the touchscreen, which provides visual feedback for the HFL system, might also display delayed or unresponsive behavior as a result of the microphone's inability to transmit signals. Recognizing these symptoms can guide technicians in confirming the diagnosis and further investigating the root cause of the issue. The first step in troubleshooting the DTC B1776 involves checking for any HandsFreeLink DTCs present in the vehicle's diagnostic system. This requires using a professional OBD2 scanner to review error codes logged by the vehicle's computer. If DTC B1776 is indicated, it confirms that there is indeed an issue with the microphone input-output system. However, if it is not indicated, it may suggest that the problem is intermittent or has resolved temporarily, meaning the system is functional at the moment. This step is crucial as it helps clarify whether the issue is ongoing or sporadic, thus directing the technician on how to proceed with further diagnostics effectively. Step 2 requires the technician to turn the ignition switch to the lock 0 position, or utilize the engine start-stop button to select the off mode. This step is critical for ensuring safety before proceeding with any electrical component disconnections, allowing the technician to work on the vehicle without the risk of electric shock or inadvertent activation of the system. Turning off the ignition effectively powers down the vehicle's electronic systems, particularly the HFL-related components, so that disconnections can be made with minimal risk of causing further issues or damage. This step prepares the way for the subsequent disconnection of the microphone and control unit connectors. In Step 3, the technician will need to disconnect the front HFL ANC microphone by removing its 8P connector. This step is important because it isolates the microphone from the rest of the HFL system, allowing for targeted testing of the component without interference from other parts. To disconnect, one must carefully pull the connector apart, ensuring no additional wires or components are damaged in the process. After the disconnection, the technician can further inspect the microphone and related wiring for signs of damage or wear. This step effectively narrows down the focus to the microphone specifically, facilitating easier and more effective troubleshooting. Step 4 calls for disconnecting the HandsFreeLink control unit connector A, which has a 32P terminal configuration. This step is crucial for isolating the HFL control unit from the circuit, allowing the technician to focus solely on the integrity of the wiring without interference from the control unit. Disconnecting this connector is typically achieved by pressing a release tab and pulling it away gently. With this connection removed, it allows for more accurate continuity testing and troubleshooting. This isolation aids in identifying any potential shorts in the wires that might be affecting communication between the microphone and the control unit. Properly securing this step is necessary to ensure a thorough and comprehensive repair process going forward. During Step 5, technicians should check for continuity between the HandsFreeLink control unit connector, A, terminal number 2, and the body ground. This procedure is necessary to confirm whether there exists a fault condition, such as a short circuit to body ground within the wiring harness. To conduct the continuity test, a multimeter will be used to probe the specified terminals carefully. If continuity is identified, it indicates that there is a direct path for the current between the control unit and the body, confirming a short present in the wiring. In such a case, the technician should proceed to replace the affected shielded harness to rectify the fault. However, if continuity does not exist, this suggests that the short is not present at this junction, prompting further testing. Step 6 involves checking continuity between HandsFreeLink control unit connector A, specifically terminals number 1 and number 2, and also terminals number 2 and number 3. This step helps to determine if there is a short between the inner wires that connect the HandsFreeLink control unit and the microphone. By performing this continuity test, the technician can ascertain whether signals are being transmitted correctly or if there is a break in communication due to shorts in the identified wires. If continuity exists between these terminals, a short is confirmed, indicating that the technician should proceed to service or replace the faulty wiring components. A lack of continuity would indicate that the issue may be at a different point in the circuit, thus directing further diagnostic tests. After completing all necessary repairs associated with DTC B1776, it's essential to perform a final repair verification to ensure that the issue has been resolved. This involves testing the functionality of the HandsFreeLink system to confirm that features like voice commands and phone calls operate effectively. Technicians should also clear any diagnostic trouble codes from the vehicle's computer and perform a retest of the system. This step verifies that the initial error no longer appears and the HFL system is fully operational. A thorough verification process ensures that all repairs were successful and that the vehicle is returned to the owner in optimal condition. Only after full confirmation should the vehicle be considered complete for delivery back to the customer. To minimize the recurrence of DTC B1776 or similar issues in the future, it is advisable to implement a preventive maintenance schedule. Regular inspections of the wiring harness related to the HandsFreeLink system will help identify any potential wear, fraying, or damage before they evolve into significant problems. Ensuring all connections, including terminal ends, are secure and free from corrosion is vital for maintaining electrical integrity. Additionally, conducting routine system checks on the HFL features can quickly catch any irregularities, ensuring that if something goes wrong, it is detected earlier rather than later. By prioritizing preventive maintenance, vehicle owners can foster longevity in the functioning of their automotive systems, minimizing unexpected failures. In conclusion, effectively diagnosing and repairing DTC B1776 follows a systematic approach that emphasizes understanding the hands-free system components, their roles, and potential fault causes. Each troubleshooting step plays a critical role in isolating the issue, whether it be through continuity checks, component disconnections, or identifying shorts in the wiring. By thoroughly analyzing symptoms and performing targeted tests, technicians can efficiently restore functionality to the HandsFreeLink system. Preventive maintenance practices should also be integrated to curb potential future issues and maintain system integrity. All these components together ensure an effective troubleshooting strategy that keeps the vehicle and its systems operating efficiently, ultimately enhancing user experience. Please like and subscribe to the channel. See you next time.